In this video, we are going to see about decoders, the second part actually. And in the previous video, we saw about decoders, we saw about basic binary decoders, and we saw about two cases, and we designed two circuits for it. And in the end of the video, I told you we'll see about 3x8 decoders, but 3x8 decoders are bit difficult for beginners, so we can go with 2x4 decoders. So 2x4, right? So as you know that decoders have n number of input lines to handle n bits, right? And 2 to the power n output lines, right? So in our case our decoder has two input lines, right? Two input lines and 2 to the power 2 output lines, right? So we'll see how this thing works. So I'll just change the color. Right, so this is very simple. Right, so just adjust the screen for now, just a minute. Right, so these are the input lines. We have two input lines, so two, right? You can name them I0 and I1, right? And we have four output lines in the sense maybe wires, whatever you call it. So four output lines. So this is a 2x4 decoder. So whatever is there coming from the input lines will be decoded and it will be sent through the output lines. So the output lines on the side we can mention them as Y0, Y1, Y2 and Y3, right? So additionally you have one more signal called the enable signal, right? So enable E, when enable is turned on or when the enable is kept high, the decoder will be functioning. If the enable is kept low, the enable will not work, right? So these are the input and output combinations and enable. And here the one thing you should be knowing that as I told you already, this input lines are n input lines and 2 to the power n output lines, right? So this Y0, right, is corresponding to the line 2 power 0, and this is 2 power 1, this is 2 power 2, and this is 2 power 3. Let's see how is this decoder working using a truth table. So I'll just write it here, the truth table of a decoder 2x4, right? So these are the inputs you have. We'll put a different color for the inputs. So input I0, I1, right? And the one more one is the enable. If the enable is kept 0, right, irrespective of the inputs, the output will be 0 because the decoder will not be working. So 0, 0, right? What are the outputs we have? You have Y0, Y1, Y2 and Y3. So the enable is kept 0, so you won't be having any output, right? So this is a case 1. And the second case, you can see the enable is kept high and the inputs are 0, 0 now, right? So 0, 0 is being given to the input side, 0, 0 in the circuit. So 0, 0 stands for, in binary it stands for 0, right? So n is 0, so 2 power 0 is corresponding to the line Y0, so 2 power 0, right? Now this line called Y0 will be carrying the data 0, 0. So the line Y0 will be enabled now. The rest of the others will be disabled, right? So this is the second case, and the third case being E is set to 1 enable and 0, 1 combination is here. So 0, 1 is given to the inputs. Just a minute, I'll just erase this. 0, 1 combination is given to the input. So 0 1 in terms of binary is nothing but 1. So n is equal to 1, right? So n is equal to 1 and 2 to the power n output lines are here. So 2 power 1 is corresponding to the line y1, right? The line y1 will be now carrying the data 0 1. So the line y1 will be enabled 1 0 0, right? So next one is you are enabling, keeping the enable high, 1 0 combination. So 1 0 combination stands for binary, it stands for 2, right? Now n is equal to 2, right? So the line that is corresponding to 2 power 2, because we have 2 power n output lines. So 2 power 2 will be carrying the data 1 0, right? 0 0 1 0, right? The last combination is 1 1 1, right? So this 1 1 1, this combination is here. So 1 1 stands for 1 1 of input to I naught and I1. So 1 1 stands for 3 and n is 3. So n is 3, the line that is corresponding to 2 power 3, that is y3, will be carrying the data y1 1, right? Y3 is now responsible for 1 1. So 0 0 0 1. So this is the truth table for a 2 cross 4 decoder, right? So you can see when the enable is not kept high in the initial stage, you can see irrespective of the input you give, even if you give 1 1 in the inputs and the enable is kept 0, there will not be any output, right? So from this truth table we can extract four equations, four simple equations, right? And using those four simple equations we will draw logical diagrams. So the first equation will be for y naught. So if you want y naught, what will be the value for input output? Input and output both are 0, so both have the complements. So I naught bar and I1 bar. So what about y1? So y1 has I naught bar, I1, and y2 has, what does y2 has have, and y naught, I naught and I1 bar. And what about y3? Y3 has I naught, I1, right? So using I naught, I1 and using 4 NAND gates, we can design a 2 cross 4 decoder, right? Let's see how we can do this. So the logic diagram can be drawn for the above equations that we got from the truth table. So the logic diagram for this decoder goes like this. So we have two inputs, I naught and I1, right? So we can draw a straight line and a straight line for this, and we need to draw 4 AND gates, right? So this is AND gate number 1, this is AND gate number 1, right? This AND gate has y naught as the output. So what are the inputs you have for the AND gate? So for the AND gates, for the inputs of the AND gates, we need a complement, right? So we need this NOT gate to complement the I naught, right? So that will be connected with the AND gate, and a complement for I1 also. So this is I1 bar, right? So the output will be I naught bar and I1 bar. And the second AND gate, it gives you y1 as the output. This is I naught bar and I1. So I naught bar is here. You can tap an input from I naught bar, and where is I1? I1 is here, and tap input from I1, and this is the third one. This is the third input, y2. Y2 is nothing but, so can take an input from I naught and connect it with the third input gate and I1 bar. So you can take can make a tap from here. So please be careful with the hooks and or jumpers, so whatever you call it, right? So make sure you are not doing any short circuiting. So the last AND gate, so this is AND gate number 4. So AND gate which gives you I3. I3 is nothing but I naught and I1. So directly you can connect I naught and I1, right? So this is the logic circuit of a 2 cross 4 decoder. Similarly, you can draw a truth table for 3 cross 8 decoders and 4 cross 16 decoders and 5 cross 32 decoders, right? That the thing is, you have to be very careful with the truth table, and from the truth table you have to form the equations for the outputs, and using those equations we can design the logic circuit, right? So if you have any doubts, you can post it on the comment section, and thanks for watching.